So when I ended the last video, I caught myself right after I hit the stop button. I said back of the book. I didn't mean back of the book. I meant back of the section. If you're following along with your textbook, that's fine. With the hard copy textbook, I'm on page 22. Since this is chapter 1, the PDF kind of matches up with that, but later in the other chapters, the PDF starts over at page 1. So it'll be a little confusing. So on the homework and when I do these videos, I'll try to put both the actual page number from the textbook and what the page is on the PDF. In this case, the PDF is only one off of the textbook. So if you're following along with what I gave you on Schoology, we're on page 23. And if you have a hard copy, I'm actually on page 22. Okay, still going to do the same thing I left off. We're going to simplify each of these expressions. So just like we saw with with opposite of square root of 50 in the previous problem, this is the opposite of the square root of 300. So I'm going to look on my perfect squares. This is from the previous video. And I know that 25 is a factor, okay? 25 times 12 equals 300. But maybe I want to find a bigger factor. 36 no, 49 no, 64 no, 81. None of these are going to be factors. A factor would be, I'd multiply this by another whole number and get 300. Okay, I know I can divide 300 by 81, but I don't get a whole number, right? 100 works because 100 times 3 works. 121, 144, and 169 is over 150, so I'm more than halfway. So I'm going to use 100 times 3. This is the opposite of the square root of 100 times the square root of 3. And I know the square root of 100, which is 10, so this is negative 10 times the square root of 3. And that's it. I still have that square root of 3 factor. For problem number 7, I'm going to multiply the 24 times 6. So I've got the square root of 24 times 6. All right, so you can do this in your head. 6 times 20 is 120. 6 times 4 is 24. So this is what's in my head. I'm going to write it down. So I got 6 times 20, and I've got 6 times 4. I'm going to add those together. In my head, I'm going to do 144. A little mental math. And if you don't want to use mental math, it's okay. Just write it all out. It's fine. Hopefully in Algebra 2 you can multiply. All right. So I get the square root of 144 in this case. That looks familiar. Going back to my perfect square sheet, 12 squared equals 144. So this just equals 12. By the way, I can't help doing this. A little bit of trivia. If I buy 12 of something, we call that a dozen. A dozen donuts, a dozen eggs, 12. If you buy a dozen dozens, you get 144 of something. Call that a gross. There you go. You're welcome. Number 8. This problem is really, really cool because I've got the square root of 72, but over here I don't have a square root in the bottom. So I'm not going to use my quotient property. I'm going to start by simplifying the square root of 72. Now, I look back at my perfect squares. 4 is going to be a factor, but maybe something bigger is going to work. 9 is also a factor because 9 times 8 equals, 9 times 8 equals 72. And what was it? 4 times 18? So 4 times 18 equals 72. I think that's right. Yes. Okay. 16, I don't think that's a factor. 25 is not. 36, but 36 is. So I know it's hard to think about this, and again, I'm using mental math, but 72 is equal to 36 times 2. So even though the 4 would have worked and the 9 would have worked, 36 actually works. And which, remember, 36 is 4 times 9, so I've got both of them in there. Now, if that is confusing, you can go back to something that we did back in Algebra 1. You can make a factor tree. 72, you can say 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. Now I factored by going to the starting with the lowest prime number and going up. Notice that right away I saw 2 times 36, so 36 was in there. So here's my 4, here's my 9, and the 4 and the 9 gives me my 36. Okay, so either way, if you want to factor it with factoring tree or whatever, that's fine. I'm still going to get square root of 36 times square root of 2 divided by 2. And that's 6 times the square root of 2 divided by 2. And finally, I can go ahead and simplify this. 6 divided by 2 equals 3. So that's 3 times the square root of 2. And that's as simplified as it's going to be. I'll move that up so you can see it. Problem number 9, square root of 80. Let's go back and look at our perfect squares. You can start with halfway. Just as another way of doing it. I don't want to confuse you. I'm just showing you different options. So 80 would be 2 times 40. So there's no 40 as a perfect square. So start with 36. That's not a factor. 25 is not a factor of 80. 16 is a factor. It's 16 times 5. So the largest perfect square will be 16. 4 also goes into it, but like I said, the largest one's going to be 16. So this is the square root of 16 times the square root of 5, which gives me 4 times the square root of 5. See you in the next video.